So hello everybody. What we will see here is not kind of the result of academia, but it's more kind of an industry or of a talk coming from practice. Because at Richiger we're not doing purely research. 1/3 of the team is doing research constantly and not implementing customer projects, and the other part of the team is trying to embed the findings from the research team into nice applications. And I want to highlight some technical details, how we actually extract data from documents. And what we do is not typical NLP tasks. Sometimes we apply NLP techniques in order to solve a particular task in post-processing once we have accessed the data. But our technology can be seen as an enabler for NLP or for text analytics, because you as researchers or decision makers from industry might know that quite often the data is locked inside PDF documents, for example. So for PDFs, best search methods are full text search, and if you want something more sophisticated, there are almost no tools out there on the market to actually access the data in your PDF documents. Here a quick outlook of the talk. First, I want to give you a motivation, then explain in detail how it works, give you the results that we achieved with these implementations, and I also want to let you know how you could actually use the technology yourself. Come to the problem statement. Left side we see potential inputs being all kind of documents. Can be scans, can be PDFs, can be emails, Word or Excel documents. And within these documents, it might be contracts, for example, or purchase orders, or any other insurance policies, for example. Inside these documents, there's lots of interesting data, and there might be thousands of these documents in your company, but you're not able to access it in a structured, machine-readable way. What companies typically do in such situations, they have some employees that just type the information from the PDF into some webmaster, for example, in order to feed the database with structured data. So it's human data extraction from documents, and quite often also human classification of documents. And all the steps that you see down here, classification, extraction of the data, semantic analysis and validation, can be automated, and that's exactly where we are putting our focus with our research. And then the output, same data but in a different machine-readable representation, could be XML, JSON, directly uploading the findings into a database or integrate them into an ERP system of a company. Here you can see the typical pipeline that the document walks through within a company in a bit more detailed way. Again, left side we see the inputs documents. It's probably all kind of documents, for example, insurance policies, some invoices, some customer complaints, etc. As a first pre-processing step, and there we are not doing research, there we are just using existing OCR solutions such as EPI, Tesseract, Google Cloud Vision or others. We have just embedded them into our technology. There we're not doing research, but then it starts with our own implementations. Typically once you have the OCR documents, you then apply classification, and I will talk about classification algorithms for documents in a minute. Once you have classified the documents into individual buckets, you then address a particular document type individually. For example, for insurance policies, you might be interested in the policy number, the first name and the last name, and the price within the insurance policy. That's the process that we call data extraction. And once we have the data, in a kind of post-processing step, quite often some analytics or validation are necessary in order to make sure that the extracted data actually makes sense and fits the customer's needs. And then finally, of course, we need to output the findings somehow and provide them via RESTful API back to the customer in the required machine-readable format. Now I want to talk about classification, data extraction, and then validation. First, I want to give you insight how it works, and then I will give you insights later in this talk about the results for the three algorithms we got. So, image-based classification is a very well-known task, and with our small team, it's not realistic to, most probably not realistic to outperform Google and others in this area. Same with text-based classification, very well-known task, and probably some people in the audience there know more than we do at Turicode about text-based classification. But what is special with documents, that sometimes it's the layout or the visual appearance of a document that might help you in order to take the decision whether this is an invoice or an insurance policy. And sometimes it's a text-based representation of a document, where you have no layout information at all. It's a pure, you can think of it as a TXT file, for example, but you lose all the information. And what we can do with our technology, we can even do some noise removal on the text. For example, headers, footers, page numbers, etc. This is just random noise in your data, which quite often doesn't help in order to take the decision. And with documents, since we know that both can help for the decision, we combined the two techniques into one model, a combination of text and image-based classification, and this actually shows the best results for documents. This might not be true for, or is definitely not true for other image classification tasks, such as ImageNet, where you have almost no text on the images, but here we have both, so we should use both. I will talk about the results we achieved a bit later. Now coming to data extraction, how it works. There it's basically three machine learning systems that we are applying to the documents. Once we know that, for example, here I think it's some pension fund document. Once we know that it's such a document, we can then apply word-level classification, where we try to find the relevant words within a document. Sometimes it's the entire document, sometimes it's just 2 data points out of a document with 1,000 pages. And you can see the relevant items highlighted in red. The feature representation is based on the text value, textual context, so we don't just have a look at the word itself, but also on the surrounding, and of course also layout information and many other information. So the vector, the default vector is about 65 dimensions when it comes to word level classification, and sometimes we add even more dimensions which might be project specific because we have some more information that might help in order to take the decision. Then the second task is about grouping data points into structured entities. We have an example here on the left side of a bank statement, and of course you want to group the line items into individual entities such that you don't have just a flat representation of extracted words, but you have grouped entities of the data, nested data structures. And finally, we do character level classification. You can see a very simple example, bottom left, where we try to identify the relevant, or try to separate the relevant characters, the actual data, from irrelevant data. Here, for example, the currency, since it was always dollar, could be stripped away. And that's the third learning system that we apply when it comes to data extraction. Again, here I will show you the results that we achieve in a purchase order task in a couple of minutes. Now I quickly want to switch. Instead of showing just a mock-up, I would like to If you look how we actually work with the documents, or how our customers work with the documents. As always with machine learning, you have training and evaluation and then production, obviously when it comes to implementing projects. So here we're in the training part, and we have two Digitech documents where there might be some interesting information, such as the address, the order date, the customer number, the description, the product number, and finally the price. So the user can annotate parts of the document simply with the mouse. I will delete this one in order not to add noise to the data. But you can imagine how we can actually label the documents like this. We have two documents in the training set, so it's a very tiny training set compared to what we've heard just a few minutes ago, and that's absolutely crucial for academia. It might work with millions of documents in the training set, but if it comes to industry, the customer would run away if we come to him and let him know that he has to label 10,000 insurance policies. So that was the main focus of our research, to decrease the training set required. Now we do a training based on these two documents. It's complete within a couple of seconds for this tiny training set. And now I switch to production, and I want to upload a document that the system has never seen. It starts analyzing it, it starts the prediction, and now we should be able to see the results. So here in blue again, you can see the words that the system identified as relevant data. And it's not 100% perfect. That would not be realistic with such a small training set. We can see one error here. This one is not recognized as a description. Top right, you can always see the F1 score, some kind of quality metrics of the system coming from the evaluation that we do based on the training set. Of course, for this evaluation, we can only use one document for training and then use the other one in the training set for evaluation. Therefore, the F1 score is not yet perfect, but already quite impressive, I would say, considering that we have not that much data. And then right-hand side, you can see the editor, where a user can then edit the data. We can there do a validation, show him warnings about invalid entries, etc. But now I want to switch back. I'm at the right place. So that was an introduction into how we do data extraction. I'll come to the result and algorithms in a second. Now here, if we talk, once we have the data, we need to talk about analytics and validation. For most projects, we have at least some parts of further analytics based on the data we got. Can be NLP, can be used for predictive maintenance. It can trigger a specific workflow within a company, being forwarded to a particular employee that should have a look at this document, for example. And if we have a look at validation, we can, for example, do anomaly detection. And we can, one thing that is very interesting is validation classification. So sometimes the user might specify a pattern that is not 100% correct, and then in production, we collect the feedback from the user, where the user, like in Tinder, has to say, was this an actual good warning, or was this just a false positive warning? It didn't match the pattern, but actually I don't care about this error, so please don't bother me in the future again with this warning. And that's just not a learning system where we can learn from the feedback from the user whether a warning that we generate during validation is actually useful or not to the user. Now I want to talk about the results that we achieved. And all the results that you see here are coming from real world cases. So here it was documents from a financial institution in Switzerland. It was all about incoming mail classification, and with mail I don't mean email, but I mean scanned documents that come per post. It was about 17,000 sample documents from 4 classes. You can see the classes in the table below. And we used a combined text and image-based classification approach. For text classification, we experimented with various approaches, bag of word and random forest being a very trivial one, and then some more sophisticated, such as pre-trained AlexNet or pre-trained ResNet 34 or ResNet 50 that we applied to the data set. And then finally, when we combined the 2 techniques, we were able to achieve these results. And to be honest, to me they were very surprising, because a human would perform significantly worse on this task. The data was extremely heterogeneous in this task. It contained even handwritten documents, and quite some handwritten documents, where OCR today is not able to extract the text correctly, typically. But somehow, obviously, within these classes, even if the text from the handwritten documents was not correct, it at least ended up with the same hieroglyphs, is that the right word in English? And the system was then able to, even though the text was not correctly extracted, was able to correctly classify the documents somehow. So the F1 scores that we achieved here, they were only a little bit lower for one particular class, being payment orders, and for the others they were very close to 1. And to me this was quite surprising, actually. I expected the F1 scores to end up at 0.9, at least that was the goal that I gave to the research team when we started with the task. Now when it comes to data extraction, there I mentioned that it's very important to have small training sets. The chart we see here is coming from purchase orders from one of our customers. We extract 8 data points here. We have 70 documents from 3 different customers in the training set, so it's 3 classes of documents, but they all contain kind of the same data schema in the documents, but completely different layouts. And again, we applied an 80-20 split and cross-validation in order to achieve the results, and we plotted the number of documents in the training set against the quality of the system. So what you see here is the learning curve, and initially when we started the research, the curve was more going like this, so we needed lots of documents until we got above 0.5, 0.7, and nowadays we were able to reach saturation very, very fast. So in the red circle you can see that from there on the system seems to be quite stable, and this corresponds to 17 documents, and that's the last time we have an F1 score below 0.95, so here again I would consider the quality to be quite significant. Now finally, how to use Mint Extract. One option is that you simply give us your data, tell us what you're interested in, and we provide you with either a RESTful API if you want to do the classification or extraction again and again, if it's not just a one-timer. If it's just a one-timer, let's say you have 50 books that you want to digitalize and, for example, generate a website out of them, then it's a one-time project, and then typically the output format is just one of the machine-readable formats, sometimes even Excel. If it comes to Swiss archives, they quite often are quite traditional, so they don't know formats like JSON and XML and want the output in Excel. But yeah, most of the time it's either JSON or XML. And the other option is that you work yourself with the tool that I've just shown you. So there you can upload your insurance policies, label the data, train the model, upload another document, perform a prediction, and edit the extracted data, finally export it to Excel, JSON, or whatever. And here as well, once you have trained your model, you can kind of release it, and then you have a RESTful API where you can upload your documents automatically and get the results back in JSON. Now, finally, that was, as I mentioned, was not pure academia. The technology is in use since 4 years already. We are constantly evolving, of course, but it's already spread across Switzerland, I would say, and we are starting now in Germany with the first customers. And we are quite proud to be funded by Horizon 2020 program. So, yeah, this is not early research, but we always try to wrap the complex algorithms into something usable. We need to build good user experience, good applications around the complex algorithms, you know, to hide the complexity and make the technologies available to basically everybody in a bigger corporate without the need for a computer science study or something similar. So if you have any questions, please let me know. Here are my coordinates. I will be around here the rest of the day, and now we have, I guess, 5 minutes for questions anyway.
Thank you, Rob. If there is any question, now we have some minutes.
I do have a question about that you mentioned that you are combining layout features and text content features to do classification. Can you maybe mention some details on how you do this combination? Do you do that in terms of merging vector representation of the text and vector, the visual representation together and then send them to a classifier, or you do that in terms of some kind of ensemble classifier, one visual part and one visual part?
Actually, sorry.
The second question is, which kind of technology do you use to extract the visual layout features?
Yeah. First question, there we tried all kind of things. First idea, as you mentioned, just combine the image vector with the text vector and then feed them into some system. Then other approaches is let both systems make the decision, make an image-based decision, make a text-based decision, and then combine the two outcomes into a kind of a super outcome or a final outcome.
Which one worked well?
Sorry?
Which one worked well?
In the end, since we used fast text, and at least I don't know how to get the feature representation from, or some feature representation from fast text, we just used the fast text outcome and added it to the image representation. And this one showed the best results, finally. And then second question was about how do we represent the layout information, is that right? Yeah. One representation is have a look at the pixels. So if I'm talking about image-based classification, then we simply use the pixels. We use AlexNet, ResNet, convolutional networks, whatever, in order to abstract from the images. Or also visual bag of word. If you want to avoid GPU and large training sets, then lightweight machine learning techniques, such as visual bag of words, is an option. But when I talk about layout information, when it comes to data extraction, there it's more about font size, font color of the word itself and also of the context. And you have this information available in the PDFs. So we use this information and not the pixels when it comes to data extraction.
How do you do that if you have OCR documents, so you don't have any information about the font?
Good OCR engines do font estimation and color estimation, yeah. It's not true for red OCR engines or for open source, some open source engines. But the best ones do an estimation and you actually use this information. There was one other question.
Thank you for your nice presentation and your exciting demo. I have a couple of questions. The first one is that I think I will draw on my view here. The OCR technology that you're using, I'm assuming that it's not 100% correct, so it induces some kind of error, which is propagated throughout the system. Right? So did you try one or more OCR systems? And if yes, were there any language dependencies, or are these systems language agnostic? And the second question is, did you try this text extraction and analysis with patent documents? Because I work with patent analysis and I would be very much interested in knowing if we can work with digitized patents.
You should try to be short because
I tried. We tried several OCR engines, and for some projects we run 2 or more OCR engines on the same document in order to find places where they do not agree, and those might be actual errors. So yes, there we tried 4 or 5 OCR engines. And when it comes to patent documents, we just started a project with patent documents, but the technology itself is completely industry agnostic, so it accepts documents in almost any language. We processed Japanese, Chinese, Russian documents, so sometimes or quite often we don't understand the documents that we are processing, but we don't care. If the machine can read them, we can feed them into the algorithm and get hopefully some meaningful outputs there. Yeah. That's the answer to the language question.
we have to stop here. Thank you very much.
Thanks a lot.